Hi Algebra 2, this is Unit 10, Lesson 2, and today we're going to talk more about graphs and zeros of a polynomial with multiplicity. So the first thing that they show us is the most general form of a polynomial. Okay, I don't want you to worry too much about that. That's written there. But we're going to talk about quadratic and linear functions are the simplest of all polynomials, but the ones that we're going to really talk about today are those with higher powers. So we're going to talk about those with x to the third and x to the fourth. So those are called cubic and quartic functions. The important thing that I want you to remember from this up here is the standard form of a polynomial is to put the exponents in order from smallest to largest. From largest to smallest. So that's standard form. I always start with the higher exponent. Okay, so we're going to look at exercise 1 and we're going to do three quick little sketches. So I'm going to want you to put these into your graphing calculator. Okay, so I got y equals x to the third minus 3x squared minus 6x plus 8. I have y equals 2x to the third minus 8x plus 9, and I have y equals 2x to the third minus 12x squared plus 18x. Okay, so put those all in your graphing calculator. They're all in standard form. The highest exponent is first, and I want you to see that all of these have an exponent of 3, so that is my highest exponent. So they're all odd, okay? And remember, odd functions always go, one end is going in one direction and the other end is going in the other direction. These are also all odd and positive. So they will all, to the left, they will be going down towards negative infinity, and to the right, they will be going up towards positive infinity. All right, so if I put this into my graphing calculator and then I look at the table, this first one right here, I can see that I have 3 roots, x equals -2, x equals 1, and x equals 4. All right, so this says 5 right there, so this is 5 here. So -2 would be about here. I don't need it to be exact. 1 would be about here, and 4 would be about here. Okay, so those are the ones it goes through. Now, if it's going down, so I'm going to put points at these because these are my 3 solutions right here. And I found those again from the table. If it's going down in this direction and it's going up in this direction, then it somehow has to do like a little loop-de-loop in the middle there to get that. Okay, so again, I'm using my calculator to get more of that shape. But we're going to learn that there's different things that can tell us about that shape in the middle. Now, if I do b, y equals 2x cubed minus 8x plus 9, I can see that there is only one root. Let me just pull up my calculator here so I can look at it. I forgot to write down what it was. So on that second one, my root is... it's actually going to be a decimal, my root, okay? It's somewhere between -2 and -3, but the root is somewhere here, okay? Again, it's odd and positive, and if you graph this, you can see that it just has that one root going this way, all right? And then it does something little like that in the middle, okay? And then the last one, y equals 2x to the third minus 12x squared plus 18x. It has a root at 0 and 3. Okay, so 0 and 3 are my roots. And again, we know to the left it's facing down, and to the right it's facing up. So in order to make that happen, it's going to be something like this. Oops. Let me just erase, sorry. It's going to be something like this. And you graph things. You're using the calculator to come up with these. All right, but that's what they look like. So the interesting thing about these are all cubics. Okay, they're cubic functions. And I have one with 3 roots, one with 1 root, and one with 2 roots. Okay, so a cubic can have 1, 2, or 3 real roots, and it can have 2 turning points. Just as with parabolas, there exists a tie between the cubic's factors and its x-intercepts. So let's look at exercise 2, which we can actually algebraically find the zeros. So I'm going to factor. So I have x to the cubed, minus x squared minus 12x. So the first thing in factoring is to pull out a greatest common factor. So if I pull out an x, I'm left with x squared minus x minus 12. And now that's a nice trinomial that I can just factor. And the numbers that multiply to 12 and combine together to give me -1 are going to be a -4 and a +3. So, and then I set each of these equal to 0. X equals 0, x minus 4 equals 0, and x plus 3 equals 0. So you can see that my answers, my roots are 0, +4, and -3. So the roots and the factors have that opposite sign. Okay, but now I know what my roots are, my solutions. So I got 0, I got -3 over here, and I have +4. Oops, sorry about that. And I have +4, 1, 2, 3, 4. Now I know this is odd, has an odd exponent, and it's positive. So odd and positive is going to face like this. So this way is going down, okay, and this way is going up. So in order to also have another root right here, it's going to have to do, whoops, it's going to have to do something like this. Whoops, and this should be more of a curve. And it would look something like that. So you can see that just by finding the zeros, finding the factors, I then know the zeros, the solutions, and knowing the end behavior, I can draw a sketch without even picking up a graphing calculator. All right, so let's look at some more here on the back. So key terms, a zero or root is a solution. And if a factor is x minus a, then basically x equals +a. So just like before, x minus 4 was a factor, but the root or solution was +4. Okay, so basically you're setting them all equal to 0, so that's going to change the sign. All right, so let's look here. Here's a graph of f of x. F of x equals x to the third minus 4x squared plus x plus 6. So how do the solutions relate to the graph of the f of x? They are the x-intercepts. So I already know the solutions because this is already graphed. So x equals -1 is a solution, x equals 2 is a solution, and x equals 3 is a solution. All right, so let's work backwards. If those are the solutions, then my factors are x plus 1, x minus 2, and x minus 3. Okay? Now I got to introduce a new word to you, multiplicity. Multiplicity is the number of times a factor appears in a polynomial. It's the exponent on a factor. So basically, these exponents right here, if there is none, these are all have an exponent of 1. So that is an odd multiplicity. So an even multiplicity is when the multiplicity, the number of times a factor repeats, is 2 or even. The graph will just touch or be tangent to the x-axis at that point. Okay, the multiplicity is even, then it just touches at that point. It's just tangent. It's going to sort of touch and just bounce right off. If the multiplicity is odd, it actually goes through the graph. It crosses the x-axis. So if you can look at our graph right here, and I think you're going to need another example to see this, but all of these had an odd multiplicity. So therefore, it went through. See how it goes through? If it had an even multiplicity, it's just going to touch and bounce off, and I'll show you what that would look like in another one. So let's sketch a graph of a polynomial in factored form, and I want to determine the following. I want to determine the degree. That's the number of possible x-intercepts on the graph, and I want to determine the multiplicity. Okay, so how the graph acts at that 0. Does it pass? Or does it bounce back? Does it go through it, or does it bounce back? And I also wanted to keep in mind that end behavior, and that's what we were talking about yesterday, the end behavior. So depending on whether it's even or odd, and if that leading coefficient is positive or negative, that's going to give me my end behavior. So there's a lot of things to think about as I'm sketching these graphs. All right, so this first one, exercise 4. Well, x minus 2 squared. Okay, so this is even. Even means it just touches. And these guys don't have an exponent, so I'm going to put ones in there just so you can see. So these guys are odd. So if it's odd, it crosses. If it's even, it just touches and bounces. So what's my degree? So 2 plus 1 plus 1, this is the fourth degree. All right, so that's also going to be even. And there's no negative sign. All right, so this is basically the n. I'm talking about the n behavior right now. It's even and positive. Even and positive, it's going to face like this, my n behavior. All right, and I should probably do that down here. Even and positive. So I'm talking about the n behavior is going up in both directions. What are my roots? So my roots are going to be x equals 2, x equals -5, and x equals 4. So those are my roots. So let's go here. 1, 2, 3, 4, 5. 1, 2, 3, 4. And 1, 2. All right. So the multiplicity, I've got even and odd going on. The ones that are odd go through. All right, and we already know that the n behavior is going to look like this. It's going to be going up in both directions. The ones that are odd are going through, and the ones that this one is even right here, it's just touching. So I'm going through at -5. I'm just going to touch at 2. So I'm touching and bouncing back, and then I'm going through at 4. All right, so these guys are both odd multiplicity. So it's an odd multiplicity. It crosses at those points. And this guy was an even. It just touches and bounces. All right, and that would be my graph, something like that. All right, so no, you got a lot of things to think about. We've got n behavior to think about. We're going to find the roots. And also now we have the multiplicity, whether it's going through at that point or it's just touching and bouncing. All right, so let's look at another one. Sketch the graph of a polynomial by finding the following. So I want the degree. This is all of these are to the first power because I have no exponent there, so they're all odd. If they're all odd, it's going through, it's crossing. So the degree, I have 1, 2, 3, so this is to the third degree. All right, so my roots are x equals -1, x equals 2, and x equals 4. The multiplicity, it's all odd. So it's going to cross at all of them. And my n behavior, if it's odd, right, they're going in different directions, it's odd and positive. Odd and positive is facing like this. That was from lesson 1. All right, so let's plot these points, my roots, my solutions. So I got -1, I've got +2, and I've got +4. I'm crossing through each of these. This one is facing this way, and this one is facing this way, and I'm crossing through each one. So it might look something like this because it's crossing. Okay, and again, these are just sketches. Let's sketch the graph of the polynomial on exercise 6. So this is even. So it's going to bounce. It's going to just touch and bounce at, whoops, I could spell that right. Maybe I'll just write touch. So it's just going to touch there. And these are odd. Okay, so those are going to cross. It's going to go through at those points. So I have 2, 3, 4. I have an exponent of 4, so it's fourth degree. My roots are x equals 0, x equals -4, and x equals 2. So I got even and odd, so some of them are going to cross and some of them are just going to touch. But remember, if this is to the fourth degree, all right, if it's even, so my n behavior now I'm talking about, so I got even and odd for n behavior and I got even and odd for multiplicity. But when I'm talking about my n behavior, it's even and positive. So even and positive is going to face like this. All right, so my roots are 0, -4, and positive 2. And I know that it's going up on the left and up on the right. Now the odd one, it goes through on the odd one, so it's going through at 0 and 2. So 0 and 2 are odd. It's going through. This one is even, and it's just going to touch. So it's touching at -4. Up here's -4, so it's just going to touch and go back up. It's going through at 0, and it's going through at 2. There we go. All right, so it sort of gives us which direction everything's going in, that multiplicity. And then last one, exercise 7. First off, notice that there's that negative sign in front, okay? So let's think of the degree. So this is 2, 1, and 1, so I got a 4th degree. So it's basically even and negative. All right, so that's my end behavior, even and negative. So that means the end points are facing this way. The roots, my roots are x equals -2, x equals 4, x equals 6. All right, so let's plot those. I got -2, 2, 3, 4, 5, 6. All right. And my multiplicity. So this one is going to be even. So it's just going to touch. These guys are odd, so it's going to cross. So it's touching at -2, but remember it's facing down, so it's just going to touch at -2, bounce back, and it's going to cross at 4, and it's going to cross, and it's going to cross here. All right, somehow my line moved. All right, a little sloppy, sorry about that. But it's just touching at -2, but it's crossing at 4 and at 6. And the end behavior, it's facing down. All right, so there's a lot to think about with all this. Here's a little sum it up. To find the roots of a polynomial function and sketch the function, we want to factor the polynomial. If x minus a is a factor, then a is a root. If x minus a to the m is a factor, then m is the multiplicity of that root. If it's an odd multiplicity, it passes through. If it's an even multiplicity, then it touches and bounces back. And then, of course, we have to think about our end behavior. So we'll practice all of that tomorrow.